Okay, class. So in this lecture, I'm going to discuss the optics introduction. Okay. Now, the first thing in optics is the lens and the mirrors. So, is in the beginning, I will discuss all the lens examples with the image formation, and then in the next lectures, I will discuss the mirrors. Okay. So now there are two types of medium. The first one is transparent medium and the another one is opaque medium. Okay. Transparent medium, you all know the examples of transparent medium like the glass, lens, etc. Okay. And opaque mediums like mirrors. So basically, what is the difference between a lens and a mirror? Mirror when you see yourself in a mirror, you cannot see what's at the back side of the mirror, but in lens you can see. Okay. When we are talking about lens or a glass, that means we are talking about a refraction. See, refraction. But when we speak about the mirrors, we are speaking about the reflection. Okay. So refraction and reflection, these are both the two things. What is the difference between a refraction and a reflection? Suppose it is some kind of an object, some kind of a medium. Okay. Let us say it is a glass. So when we speak about refraction, that means a light is traveling like this, and when it is passed through a glass, it will bend and it will change its direction. Okay, it can go like this, it can go like this, it can go like this. Any case it can go. Okay, but when we speak about when it goes from one medium, it is one medium and this is another medium. Okay, but when we speak about, suppose this is a medium, this is a mirror, opaque medium. So when we pass any light, it will not go like this, it will bounce back itself. Okay, light does not pass, but it will bounce back. So this is your reflection. Okay, do you understand the difference between refraction and reflection? So I have mentioned here, light bends, light is bending, it changes its direction from one medium to another medium when it passes through. But what do you mean by reflection? Light does not pass but bounce back. Okay. So now in this lecture, I will speak about only the transparent medium, that is the lens. So I will speak about refraction, no reflection. Okay. Reflection, we will discuss it later. So I have mentioned, what do you mean by lens? Lens is a transparent medium. That means what is the process which will occur? It is a refraction. Okay. So I have mentioned here, it is a transparent refracting medium having two surfaces of which at least one is curved or both are curved. Okay. Like you can say, suppose, let us say this one. Is it a lens or not? No, it is not a lens. Why? Because none of the surface is curved. Both are flat. Okay. Suppose this. Okay. Is this a lens or not? Yes, this is a lens. Why? Because one of the surface is curved. Okay. Let me give you another example. Okay, tell me, is it a lens or not? Yes, this is a lens because both of the surfaces, this surface and this surface, both are curved. So this is a lens. Lens, no lens. There is no lens. It is a lens, right? It is a lens, right? Now let us take another example. Okay. Okay, tell me, is it a lens or not? Yes, this is a lens. Why? Because both of the surfaces are curved. Okay, now another example. Okay, tell me, this is a lens or not? Yes, this is a lens because one of the surface is curved and one is flat. So for lens, what must be the condition that both of the surfaces or at least one surfaces must be curved. If both the surfaces are flat, then it is no lens. There is no lens. Okay? So I hope the definition of lens is clear to you now. Now what are two types of lens? Convex and concave lens. Okay? Convex lens are also known as converging lens. Concave lens are known as diverging lens. I will explain you what do you mean by the converging and what do you mean by the diverging. First, we will write the definition. If we are talking about convex lens, that means it is thicker in the middle and thin at the edges. Okay, when I am speaking about convex lens, concave, it is thinner in the middle and thick at the edges. Always remember this definition, it is very important. What is thin, what is thick? So convex lens always thin at the, okay, now come again on this one. Can you tell me, okay, I'll give you another example. When I'm speaking about convex lens, okay, that means it is, okay, now you can see it is thicker in the middle and thin at the edges. So you can see it is thicker in the middle and it is getting thin at the edges. So this is your convex lens. Okay. Now there are three classifications of convex lens. 1, 2, and another one is this one. Sorry, it's very dirty. Okay. Like this and this. So these are three classifications. Let us say the first one. First one is a normal convex lens. So we can say biconvex lens or double convex lens. Okay. Why bi? Bi means two. So both the sides are curved. Okay. Next one, this one is plano convex lens. Plano convex lens. Why it is plano convex lens? You can see basically it is a convex lens because one of the side is curved and another side is, this side is plane. Okay, if it would have been like this, that means both the sides are curved, so that means it is a biconvex lens. But if it is like this, that means it is a plano convex lens because one of the side is plane and another one is curved. Another one, okay, I will give you this name later after doing the concave lens. Okay. Now the another one is, see, okay, suppose this is a convex lens like this, and if any parallel rays are coming like this, okay, see the parallel rays are coming. Okay, what will happen if parallel rays are coming? They converge on one point. Okay, they will converge on one point when it passes through the convex lens. This thing we will read in detail, we will study in detail in my next lecture. Okay, converge means they, after passing through the convex lens, they will meet at one point. This is known as converging. Okay, so convex lens are always converging. Always remember, C convex and they are converging. So I have written here, if parallel rays are incident on convex lens, they converge on one point after refraction. Okay, convex lens converges parallel rays of light and hence it is also known as converging lens. Okay, so this is all about the convex lens. Now come to the concave lens. Always remember what is concave lens. I told you it is thin at the middle and thick at the edges. So you can see that it is thin in the middle and thicker at the edges. Okay, so there are again three. This is a normal concave lens. Another one is like this, like we have studied in convex lens also. And the another one is okay. Now we will name it. The first one is normal. See, both the sides are curved, but it is a thin in the middle. So I will write by concave lens or double concave lens. Okay. Next one, as we did it in the previous example, one side is plane, so I will write plano, and another one is concave. So it is plano concave lens. Okay. Now next one, see this one first. Now if you see this, what is this type of lens? It is basically a convex lens. You can see it is a convex lens, right? But the another side, this side, is not plane. It is like when you see a concave lens, the one side is like this. So you can see the one side is like this. So basically it is a convex lens, but the concave part is also there. So I can write it is a concavo convex lens. Okay, this is a concavo convex lens. Okay. Now the another one, can you name the another one for concave lens? Okay, let us see. Yes, this one. Try it. So see, this is a convex lens, right? So one side, this side is basically a part of the convex lens, and concave lens is this one, and another side is a concave lens. So it is basically a concave lens, but a part is convex lens. Okay, so I can say what is the name of this one. So the name of this lens is convexo concave lens. I hope this is clear to you now. What is convexo concave, plano concave lens, and next one is biconcave or double concave lens. And here biconvex lens, double convex lens, plano convex lens, and concavo convex lens. So these are the classifications of all the concave and convex lens. Okay. Next is basically concave lens are known as the diverging lens. Okay. Concave lens diverges parallel rays of light, hence it is called diverging lens. So I'll just give you this is a concave lens like this. Okay, so when a parallel rays incident on it like this, so what will happen to the parallel rays? The first it will diverge like this. So this is called diverging lens. So in convex lens, what is happening? They are meeting at the same point, but in concave lens they will diverge. Okay, that's why concave lens is known as the diverging lens. Now there are some of the terminologies we will discuss, and these terminologies are very important. If you will understand these terminologies, then and only then you will be able to do the image formation. The first one is center of curvature. Now what is center of curvature? Okay, let us draw an example. Let us draw a figure first. Suppose this is a lens. I'm drawing the lens. Okay. And if you see this lens, this part basically. So this is a part of a circle. Okay. And this part is also a part of a sphere. Okay. So we will draw this. So if I will draw this like this, okay, and this also I will draw like a sphere. Okay, let it is a bit smaller, so I'll just make a bit bigger. Okay, let me draw it again. Okay, so just assume this is here. So this is a part of the. Okay, wait, let me draw it once again because I need to copy paste this. I'm very bad in drawing. Wait. I think it will come better. Yes, this is a bit better. Okay. So basically these two spheres, these are the part of the sphere. So what will be the center of curvature? I'll show you now. Let me make it dotted. Okay, and let me copy paste this one in the in radius of curvature. I'll explain this. Okay, and in principal axis as well, in pole, in optical center. Okay, so yes, so center of curvature, if I'm speaking about center of curvature, that means there is a lens like this, it is a circle, it is a sphere like this, so there will be a center of the sphere. So this is your center of curvature. Okay, so I will just mention, so this is a lens, this is one circle, and the center of the sphere is this one, and this is the center of, okay, it is not the center. Okay, this one is the center, this one is the center of this circle, and this one is the center of this sphere. So these 2 points are basically the center of curvature. Okay, you understand this? Center of curvature, it is a center of a sphere from which the spherical surface of the lens is obtained. Okay, that means there is a sphere, and there is some part from which the lens is obtained, but it is basically a part of a sphere. So this center is known as a center of curvature. Okay, now the next thing is radius of curvature. It's very simple. So you identify the center of curvature. This was your center of curvature, right? Now what will be the radius? Radius will be the radius of the sphere. So this is your radius. Anything, anyone, any part, this is your radius. This is your radius. This is your radius. So anything from the center is the radius. You all know, if this is a center, then it is a radius, and this hole is a diameter. So this is your radius of curvature. So definition is mentioned here. It is the radius of the sphere from which the spherical surface of a lens is obtained. So this is your radius of curvature. Okay. Next is your principal axis. Now what is the principal axis? First of all, always remember principal axis is the imaginary axis. Like when we do the mechanics, we do the x, y, z axis, right? X axis, y axis and z axis. Okay, but these are imaginary axis. Same with the principal axis, It is a straight line passing through the two center of curvature of a lens. So if it is a lens and this is your center of curvature, this is your center of curvature, so there will be an imaginary line which will pass through both the center of curvature. So this is your principal axis. So I mention it with P. P is your principal axis. Remember, this is the imaginary line. Okay, and we always show it with the dotted line. We never show it with the solid line. Always show with the dotted line. Okay, so this is your principal axis. Next is pole. What is the pole? It is the center of the spherical surface on principal axis. Suppose this is your principal axis. Okay, let me copy this picture on here. Let me copy this picture. So this is here. Okay. So look here. What is pole? It is the center of the spherical surface. When we are speaking about pole, that means this is your pole, P, and this is your pole. It is the center of the spherical surface on the principal axis. Okay. Always remember, pole will be always on the principal axis. Okay. Okay, let me delete this. We'll take the previous picture. Let me copy this picture. Now, next one is optical center. Optical center, it is on the principal axis. It is the center of the lens. So when we speak about the optical center, always remember, we'll just draw a line like this on the center, and this point is your optical center, and we denote it with O. O. So this is your optical center, and it is always on the principal axis. So pole is this one, and optical center is the center of the lens. Okay. Next is your focal point. What is your focal point now? It is a point on the principal axis at which parallel rays of light either converge or appear to converge. Okay, why it is written as converge or appear to converge? I will explain you now. So I have shown here two lenses. One is convex and another one is concave. So I am writing here, this one is convex lens and this one is concave lens. Okay. Now, always remember, when I'm talking about convex, concave, just make a line in the middle like this. Okay. Now, when the rays are parallel, okay, suppose I'm just drawing this line here. This ray is incident and it will bend. Okay. It is bending. So this ray is also incident like this and it is bending. Okay. So this is going in this direction, this is going in this direction. So they are meeting at one point and this point is known as F, or the focal point or the principal focus. Okay. Convex lens, always remember, we did convex will be converging. So the rays are converging. Now if we talk about the concave lens, suppose a ray is, this is a ray which is incident here. Okay, and now it will diverge. You all remember, when we are speaking about concave lens, it will diverge. Okay, so suppose this is a ray which is parallel and this is diverging again. Now because they are not meeting here, but they are appearing to meet. So we are just extending it like this, and I am extending it like this. So wherever it is meeting on the principal axis, this is the focus point of the concave lens. So I have mentioned either converge or appear to converge. So when it is converge, that means we are talking about, sorry. Okay, when it is converge, that means we are talking about the convex lens. But when it is appear to converge, that means they are not basically meeting at focal point. They are appearing when we extend it. Okay, so it is F. So it is basically a virtual point, not the real point. So convex and concave lens. Another one is focal length. Always remember, focal point is denoted by capital F. Okay, but focal length is denoted by small f. Now what is this focal length? Okay, we will just copy this picture, both the pictures. Okay, let us copy this first, paste it here, and let me copy this picture and paste it here. Okay, now what is the focal length? See, distance between optical center and focal point is called focal length. So can you mark it on the figure? Distance between optical center. Which one is optical center? Okay, this one is optical center, right? You all know this one is optical center. Okay, this one is optical center, and on this picture this one is optical center. Now distance between optical center and focal point. So what is the focal point? This one. So what is the distance? This point and this point is the focal length. Now this point and this point is the focal length. Okay. So I hope it is clear to you what is focal length. Distance between the optical center and focal point is the focal length. Always remember, F equals to positive for convex lens. Okay. And F equals to negative for concave lens. Okay. F equals to positive, that means focal point on the, it's not on the same side, it's the different side. Okay, opposite side, other side in convex lens, and in this on the same side. Okay, same side. Now